I'm Cara, and we're going to be looking at a multiple choice question about organic synthesis. Okay, so the question is, cyanide ions react with haloalkanes and carbonyl compounds. Which rows give the correct mechanisms for the reaction? And these are the options. So you've got different kinds of substitutions on the left with haloalkanes and different kinds of additions on the right with carbonyl compounds. So the options are different combinations of electrophilic and nucleophilic. So to start this question, you might want to recall what a nucleophile and electrophile is. So a nucleophile is an electron pair donor, and an electrophile is an electron pair acceptor. Here we've got our haloalkane. So to start, let's just draw on the deltas. So we've got a delta positive with carbon and the delta negative on whichever halogen we've got, so here's chlorine. And when we're thinking about this, we've got to remember that the cyanide ion has a lone pair. As you can see here, we've got an extra electron, which is why it's a negative ion, and the lone pair on the nitrogen. So what's going to happen is the lone pair on the nitrogen is going to attack the carbon, which is where there's the delta positive, and then the lone pair from the covalent bond is going to move to the chlorine. And then, so the cyanide is going to substitute the chlorine, so we're going to get the chlorine ion there, and that is going to be our product. And so if we go back to the question, so now we know because the cyanide ion has donated an electron pair to the carbon, it has substituted it nucleophilically. So we know out of the options it cannot be A or B because it's electrophilic and it is nucleophilic. Now for the carbonyl compound, we've got the same cyanide ion, and basically what's going to happen is the lone pair on the nitrogen again attacks the carbon, which is where there's the delta positive and the delta negative on oxygen. But this time, one of the electron pairs in the double covalent bond goes to the oxygen, and so our product is going to look like that. And basically, instead of substituting, like for the haloalkane, it is addition, and in the same way, this substitution was nucleophilic. It's behaved the same way, so it's nucleophilic addition, not electrophilic addition. So out of our options, you can cross off that one because it's not electrophilic. And we know that it must be D because it's nucleophilic in both cases.